Okay, so we're going to finish up 5.3, hopefully not in as long as it took for the first part of 5.3. But we ended the last video with this definition of elasticity of demand. Elasticity of demand is given by a negative P times F prime of P over F of P. F of P is your quantity demanded, and P is your price. And we talked about how if I evaluate this function right here, this formula, at a certain price point, P sub 0, let's say, if it's greater than 1, what we say is it's an elastic, okay, demand, price demand, and if it's less than 1, it's inelastic. So here's what those two things mean. So elastic, here, again, we're looking at a change in price versus demand. So elastic says that a small, and this is all true for small changes in P, a small change in price will result or will cause, okay, if it is elastic, a large change in quantity. And that is usually, well, of course it would be, their quantity would go down and quantity demanded. Okay, so if we have an elastic system, a small change in price will result in a large change. Sorry about that. I am not an English teacher. Change in quantity demanded. And if I have an inelastic system, okay, or an inelastic scenario, then a small change in price will result in a small change in quantity demanded. And let's do an example. Okay, so I just want to do basically, we'll maybe do 2 examples, maybe just one. We'll see how long this takes. And then what we want to talk about is how does this affect our revenue? Because it doesn't necessarily, yeah, anyway, that's what we want to talk about. Okay, so let me get my example out. Yeah, all right. So example, the demand function for a certain commodity I hope I spelled this right. Oh well, if I don't, huh? Can I teach math? Is given by, or is, okay, so I have a demand function, we'll call it Q, which is a function of P, and we'll say that this is 160 minus 4P. Notice how it has a negative slope, okay? So let's find what is the price elasticity of demand at 2 of demand when P equals, we're going to look at 2 prices. When my price is set at $15 per unit and when P is equal to $25 per unit. Okay, so what is the price elasticity of demand when my price is either $15 and when my price is $25? Okay, so let's remember E of P equals a negative of P times F primed of P all over F of P. Where what is my F of P? My F of P is this guy right here, 160 minus 4P. So, whoa, sorry. I keep messing up my ink flow here. So let's find out what E of P is, okay? We'll just, because I know I'm going to be plugging in different P's, I don't actually want to plug in my P's quite yet. So I would have a negative P times the derivative of this guy right here with respect to P, which is a negative 4, all divided by just the function itself, right? Which is 160 minus 4P, okay? All right, so let's see what we got here. This is easy to simplify. This would just be 4P over 160 minus 4P. You may not cancel out those 4P's, people. Don't do it because this is subtraction. You may not cancel this out. Don't do it. Don't ever do it. Do not ever do it. Thank you. I'm glad we have come to an understanding. So here's my price. This is my function for my elasticity. So let's plug in some numbers. So if I plug in 15, okay, so obviously I would get 4 times 15 all over 160 minus. All right, so sorry if there was a break in the video there for a second. I had to make sure my computer wasn't going to be doing weird stuff. All right, so 4 times 15, that's what, 60? So 160 minus 60 is 100. Okay, so if I simplify that, I can cancel the zeros. I get 6 over 10, which if we take a 2 out, we get 3/5. So this is less than 1. So what do we know? Inelastic. And we'll talk about what that means here in 1 minute. And then what is E of 25? E of 25 would be 4 times 25. That's 100 last time I checked. 160 minus 4 times 25. Okay, so I get 100 over 60. So it's just the opposite here, or the reciprocal. And I get 5/3, which is greater than 1, which is elastic. So let me explain, get my hand right here, what these mean. So again, what does it mean to be inelastic? It means a small change in price will result in a small change in quantity demanded. And what this 3/5 means basically is, let's say I change my price by 1%. Okay, so I'm going to increase my price of whatever this deal is by 1%. Then what that 3/5 means is that my demand, my quantity of demand, will only decrease by 3/5 of 1%. Okay, so 3/5 of a percentage. So what that says is that even though, if it's an inelastic system, even though I'm maybe making a 1% change in price, it will only result in a less than 1% change in demand. And my demand will go down because I'm increasing my price. Also over here, if I look at 25 in an elastic system, if I make a 1% change in price, that is going to result in a 5/3, right? Which is what, 1.7 about, right? So if I just make a 1% change in price, what that 5/3 says is that I am actually going to make about a 1.7% decrease in my quantity demanded. So a small change in price could result in a larger relative, right, all relative change in quantity demanded. I hope that kind of makes sense. What I'd like to look at now is, how does this relate to our revenue? So if I look at this function right here, if you remember, let's actually just get a brand spanking new. Oh, whoops. I'm actually just going to add a layer. Okay, so let's look at layer 3, and let's go, I want to look at the same function. So we had our quantity, right, was 160 minus 4p. So what is our revenue? Our revenue, remember, this is the quantity that I have, so our revenue, remember, revenue equals price times units, how many quantities I have. How many quantities I have, how many I'm selling. So my revenue then, which I can consider a function of P, is my price. So that would be P times the quantity, which is 160 minus 4P. So let's look at our revenue here. I would get 160P minus 4P squared. And if we graphed this, so this is the big deal with elasticity, right? Like, what is this going to do to our revenue? And if I found the zeros of this, I'm going to be at 0, 0 here. And I think it's, if I plug in, oh, I did this, 40, I think I'm at 0 as well. So this is 40, and this obviously is a parabola facing down. And if we take the derivative and set it equal to 0, we see that when you take the derivative and set it equal to 0, you get 20. So I know I have a maximum revenue. Okay, I'm just going to move. I'm going to move this 40 bit over a little bit. This is lovely. Yay. If it doesn't do what I want it to do, I'll just change it. All right, we'll make this 40 then. That looks a little better anyway. Okay, so this is my revenue. This is my price. Okay, and if you look at your elasticity of demand, okay, which I know elasticity of demand here is 4P, which we found before. all over 160 minus 4p. Notice if I take my elasticity, oh my goodness, Sarah, let's just use that. There we go. And I look at 20 here, okay? I want to look at where my elasticity is positive and where it is negative. So, or not positive and negative. I am so sorry. Greater than 1 or less than 1. If I plug in, let's plug in the number 1, right? Then what you notice, so I'm just plugging to the left of 20. If I plug in the number 1, I would get 4 over what? Oh, 156, right? Which is definitely less than 1. And if you take this number, if you take a number bigger than 20, what we're going to see is we're going to get E is greater than 1. So the interesting thing about this, if I look at my revenue function, if I draw a dotted line at where my maximum revenue is, what we see is that E of P here is going to be greater than 1, okay? And over here, my elasticity is going to be less than 1. So look at what happens on the right-hand side here. If I have an elastic system, my revenue decreases. It's getting smaller, which isn't always a bad thing, right? And if it's less than 1 over here, and if it's inelastic, my revenue increases, which kind of makes sense. If it's inelastic, then as I'm increasing my price, my change in quantity isn't very large, so it would make sense that my revenue increases. Over here, my revenue would decrease because if I'm elastic, then a large change in price results in a large change in quantity demand, and my quantity is going to go down. Okay, I hope this kind of makes sense. The other thing that we need to note here, and this is a pretty big deal here. So the change in revenue okay, the change in revenue, well, actually, I want to say this a different way. Sorry. If my system is elastic, okay, if my system is elastic, then the change in revenue, so elastic, right? What do we see here? That would be this guy right here, elastic. My change in revenue is opposite. Oh, why isn't this working? Huh. I don't know what just happened there. Sorry, guys. 1 second. Okay, sorry about the, that was a little weird, I bet, watching the video, but my tablet stopped working, so I had to redo that. Okay, so where were we? A change in revenue. Okay, let's see if this is going to work. Okay, there we go. Sorry about this, guys. So my change in revenue is in the opposite direction. Oh, goodness. Opposite direction as my change in price. If we have an elastic system, in the opposite direction of the change in price. So what that means is if I'm increasing, well, let's look at the elastic system here. Okay, so elastic system right here. A change, notice my revenue is decreasing, but what's happening? My price is increasing. So they're in opposite directions. That's what that's saying. So it's interesting if we look at it, if we know our system is elastic and we want to know what would happen. So my system's elastic. If we want to think about making a change in my price, if I'm going to increase price, that's going to decrease revenue. Whereas if I decrease price, that will increase revenue. They will be in the opposite direction of each other. And then likewise, if we're inelastic, right? If I have an inelastic system, okay, then the change in revenue is in the same direction. The same direction as a change in price. Direction of the change in price. So let's look at that. So what this is saying, right, is notice my revenue is increasing. So R is increasing here as P is increasing. So they go the same way. So if I have an inelastic system, if I increase my price, my revenue will increase. If I decrease my price, my revenue will decrease. And these are for small changes in price. Okay, so let's look at an example. We'll clear this guy out. Okay, last example. This has been a very, very long video. I guess you're getting your money's worth, right? Okay, so last example, and then we'll be done. Of our last video for the semester. That's kind of sad. So a company, okay, can sell. Now this is going to be awesome. Look at this function. Can sell, and this, here's my demand function. Q equals, this will be fun, 1,000. I want to show you one that's not linear. P squared, they don't always have to be linear. E raised to the negative 0.02 times P plus 5. I know that's a little crazy. A little cray-cray, as you kids call it, I'm sure. So a company can sell this many, that's my demand. And of course, we're talking about calculators. So this company is selling calculators at price P. At a price of P dollars. So there's my demand, and we have a price of P dollars. Oops, per calculator. Okay, the current price per calculator, I'll just put the current price, is 200 bucks. Ooh, that's a nice calculator. Okay, if the price should, how about should the company increase or decrease the price in order to increase revenue? So again, now remember, revenue is not the same as profit, right? So that's a whole nother thing that we could be figuring out, because what is, if we were given a cost function, we could figure out, well, what would our actual profit be? So a company can sell that many calculators at a price of P dollars per calculator. The current price per calculator is $200. Should the company increase or decrease the price in order to increase revenue? So what we have to figure out, people, is we have to figure out, is this an elastic system or an inelastic system? Okay, so in order to do that, we need to find E of P, my elasticity, which again is a negative P times F primed of P. It's going to be fun, all over F of P. All right, so here's what we get. Negative P, okay, times the derivative of this function right here, which we need to do. Yes, you got it. I'm excited too, the product rule. So let's leave the first. Oh, I hope I'm going to have enough room. Times the derivative of the second. Remember, for E, we just rewrite it. Oh, I'm not going to have enough room if I write like that. I need to put my ink flow down a little bit. 0.02 times P plus 5 times the derivative of the exponent. Well, if you took this negative 0.02 through, basically your derivative would just be a negative 0.02 with respect to P there. Okay, so leave the first times the derivative of the second plus leave the second times the derivative of the first. So the derivative of the first of this guy right here is 2,000 P, right? Bring that 2 down and then leave the second. Times P, plus 5. Darn it, sorry about that. All over F of P. So I just rewrite this. We can't cancel the one. Well, we actually will bring the 1,000 out. E to the negative 0.02 times P plus 5. This guy actually turns out to be really, really nice. So what I can do right away is I'm going to cancel this P with one of these P's. I can do that, people, because this is a multiplication sign right here. And this P is multiplying the entire numerator, right? There's a big parenthesis here. And that P is multiplying the entire numerator. And then what else am I going to do? I'm going to factor out on top here I'm going to go ahead and factor some stuff out. So I'm going to factor out a 1,000, and I'm going to factor out this e thing. So I'm going to take out a 1,000 e to the negative 0.02 times p plus 5. Okay, and let's see what we have left. If we do that, I get a negative 0.02 p squared plus 2,000. Okay, and all of this is over. All that crap on the bottom. 1,000 p e to the negative 0.02 times p plus 5. This is a pretty nice one, actually. It doesn't look nice at first. My thousands cancel, my e's cancel, and I'm just left with that p on the bottom. All right, so here's what we got. We have e of p then. My elasticity equation here turns out to be pretty nice. Negative 0.02 p squared plus 2,000 all over p. Okay, so what do I need to figure out now? I need to figure out, well, what is my elasticity at $200? So let's do it. Let's see, is this system at $200 elastic or inelastic? That'll tell me, should I increase or decrease my price to figure out my revenue? So if I plug this in, times 200 squared plus 200 all over 200. And I hope I did this on my calculator correctly. Oh, come on, Sarah. Where's your calculator? Anyway, here we go. All right, so 200 squared, so negative 0.02 times 200 squared plus 2,000 is 1,200 on the top, all over 200. And those cancel out, and I get 12 divided by 2, which is 6. Okay, so we get 6. I hope I did that right. Negative 0.02 times 200 squared plus 2,000. I think I did. Well, I think it's pretty close. All right, so I get 6. What does that mean? 6 is greater than, if that number's not right, I apologize. It might be 4. I don't know. I was looking at my notes and I have that it's 4. So you check it. But this system should be elastic. So 6 is greater than 1. Therefore, what do we know about this system? It is elastic. So what do I know about a system that is elastic? Oh, did I erase it? No, I didn't think I did. What do I know about a system that is elastic, right? I know that the change, I know that the change in revenue is in the opposite direction of the change in price. So what do I want to happen, people? I want an increase in revenue. So because I know it's an elastic system, oh my goodness. Because I know it's an elastic system, if I want to increase revenue, I want revenue to increase, then what must I do to my price? I must drop it. Because I know revenue will go in the opposite direction of my price if I have an elastic system. So should the company increase or decrease the price? The company should decrease the price because it's an elastic system. And revenue goes the opposite direction. All right, I hope that makes sense. If you stuck with me through this whole video, both parts, really through this whole semester, I applaud you because that was a really long video. That was like almost 50 minutes total. But I hope that helped because this is a really important concept. And if you have any questions as you're going through the homework, please let me know.